Dear friends, welcome to yet another installment of Orbital Geek. In this video, we delve into the most fascinating theories about the genesis of our cosmos. From the colossal primordial explosion to the enigmatic cosmic singularity, through the inflation theory and the innovative ideas of colliding branes, we unravel the mysteries surrounding the creation of the universe. Could our existence be just an endless cycle of parallel rebirths? Get ready to expand your mind, just like the universe itself. But will you be ready to question all your beliefs? Watch until the end to find out. How did our universe come into existence? And if that question seems too daunting, consider this. What was there before our universe? As scientists seek to answer the most intricate question in history, let's explore what they have discovered so far. Your comment is invaluable to us. It helps the algorithm recommend our videos to more people, which is crucial for the growth of our channel, especially at the beginning of this journey. If you can, leave a comment, even a simple hello. Your participation makes all the difference. In the 20th century, we unraveled this mystery thanks to one man, Edwin Hubble. Once, at Mount Wilson in Southern California, he pointed his telescope at the firmament and discovered that those apparent random clouds of gas are, in fact, other galaxies, and there are myriad of them. Moreover, he made a discovery that changed our understanding forever. Those galaxies are moving. And what does that mean? It means something monumental. The universe is expanding. And if it's expanding, then it probably had a beginning at some point in time, right? Now, just go back in time and find that starting point. It took years until scientists reached a complete theory, the Big Bang theory. And here it is. Nothing was ever anywhere, because neither when nor where existed. Understand? But no, there was actually one thing. It was the so-called cosmic singularity, a state of our universe when it was incredibly small, dense, and extremely hot. Imagine if we condensed all the vastness of our universe into a tiny little sphere. The pressure and temperature inside would be unimaginable. At a critical point, it became impossible to sustain them, and then came the Big Bang. It was a primordial thrust of energy and matter that created everything we see now. The space-time fabric itself, the fundamental physical forces. It also scattered quarks everywhere. Those tiny quarks that make up our world, they were all boiling in an incredibly hot cosmic broth. When it cooled, gravity began attracting them to one another. They joined into atoms, then molecules, and then into the first objects of the cosmos, stars. All of this happened between 12 and 14 billion years ago. Well, now we know how our universe was created, but what was there before that? Alan Harvey Guth, an American theoretical physicist and cosmologist, devoted his entire life to solving this mystery. After learning about the Big Bang theory, Guth found some flaws in it. For example, the matter distribution was too uniform when it shouldn't have been. Imagine hanging a balloon filled with paint from the ceiling and stretching out a white screen on the floor. If we drop the balloon, it's going to explode and we'll see absolute chaos on the screen. A jumble of randomly scattered splashes, no two alike. But that's not really how the primordial universe seemed. Instead of dropping a ball of colors from the ceiling, draw a tiny red dot on the screen. Now gradually expand it, a little more and more, capturing it all in slow motion. You'll see a circle growing smoothly and uniformly in all directions. That was the reality. The primordial universe was remarkably homogeneous. That was Guth's discovery, the inflation theory. Here's what it postulates. Even before the Big Bang, there was some kind of force capable of hugely accelerating the bang, something that could instantly and uniformly distribute everything across space. Guth's theory was a great success, and today the vast majority of scientists embrace it. For most, this majestic idea of the birth of the universe is more than enough to quench the human spirit's thirst for cosmic knowledge. For most, but not for all. Martin Bogerwald, a visionary German physics professor, believes the universe was born in a very different way. Remember when we talked about the cosmic singularity, that primordial state of the universe, when it was incredibly small, infinitely dense, and extremely hot? According to Martin's theory, the The singularity could not have simply sprouted from nothing. That would be a cosmic absurdity. But then, where did it come from? Look at the pendulum of an antique clock. It swings back and forth. Its motion is smooth, continuous, uninterrupted. That's how we normally conceive of time, as an endless flow. But quantum time, quantum time. It doesn't work like that. It's more like the second hand of a clock. It consists of tiny discrete segments, making little pauses. And just like with the second hand, the start of one time segment is always the end of another. Get it? Back to the balloons. According to the Big Bang theory, at some distant point in the past, our universe began expanding, inflating like a balloon. But sooner or later, it will burst back again. The universe starts contracting and returns to the state of cosmic singularity. And then, guess what? The Big Bang again. Nothing comes from nothing, and nothing returns to nothing. According to Bojewald's theory, the beginning of each universe is the end of the previous universe. Our universe is by no means the first, nor will it be the last. Millions of similar universes existed before us and will exist after us. This theory, though it may seem logical, is far from being complete. Unfortunately, we don't have enough knowledge to find all the evidence for it, so for now, it's just an admirable hypothesis. But some minds present even stranger and more portentous ideas. Scientists propose theories so unusual that no person could even imagine them. Neil Turok, a visionary South African physicist, and his colleague Paul Steinhardt, a prominent American theoretical physicist, seek answers far beyond our single solitary universe. They postulate that yes, our universe is not the first. There have been and will be an infinite number of them, and not only will there be infinite Big Bangs, our universe is just one of an infinite number of others, and we're all trapped in an endless cycle of parallel rebirths. This sounds both incredible and terrifying at the same time. But how does it work? According to this theory, our universe is located within a so-called brane, as in membrane. In other words, we are trapped on some kind of elastic surface capable of contracting, stretching, oscillating, and so on, like pieces of fabric on a vibrating string. Those parallel universes are located very close to one another. Each has a neighbor. We are no exception. Another universe may be an inch away from ours, but we cannot see it. This is because there is a tiny gap between us, and this tiny gap contains the fourth dimension. How do those universes originate? Through the collision of branes. Those branes are approaching each other very, very slowly until one day they finally collide. Their collision creates two Big Bangs and two parallel universes. Then they are moving away from one another. The created worlds continue living. This is the stage we're currently at. But when they die out, the branes collide again, and this will lead to the birth of a new universe. Remember the inflation theory? There was a mysterious energy that pushed and accelerated the Big Bang. Well, if we really did collide with another universe, that would explain it all. Of course, everything described here is a gross oversimplification. When you hear that our world is a piece of fabric on a vibrating string, it sounds like a complete absurdity. But this bold idea is based on string theory and M theory, two Herculean giants of quantum mechanics. If proven true, they could explain nearly everything in our vast universe. Creating a revolutionary theory is an incredibly arduous process. Neil Turok and Paul Steinhardt performed a prodigious amount of calculations and swept through countless fruitless theories. Moreover, to work on this, they have to transcend the very limits of the human mind and conceive 11 dimensions at once. Unfortunately, this elegant and daring idea was ridiculed. Turok and Steinhardt say scientists themselves are just regular human beings. They too fear change and the unknown, and it's really terrifying to question everything we believed in before. Many centuries ago, people didn't believe the Earth was spherical. Then, they were outraged by the revolutionary Big Bang theory. We cannot make big discoveries without struggle and fear. That's why Turok and Steinhardt don't plan to give up so easily. After all, the evidence we have now only says each of the three theories is equally possible. So, what is the right answer? At least not at this current stage of human development. Unfortunately, as long as we don't have substantial evidence, we can only theorize. But maybe one day, we'll find something that will open our eyes once and for all. Maybe one day, we'll solve the deep mystery of how our universe arose. However, after thoroughly analyzing the major scientific theories about the origin of the universe, it's evident that there is still much to unravel. The Big Bang, singularities, cosmic inflation, multiverses, everything indicates that we are barely scratching the surface of a much greater mystery. Nonetheless, it is encouraging to see the persistence of brilliant minds like Alan Guth, Martin Boyerwald, Neil Turok, and Paul Steinhardt, striving to unveil the deepest secrets of creation. After all, as Galileo Galilei said, nature is written in the language of mathematics, and these modern physicists are deciphering its complex lines. But what about you? Are you ready to have your most deep-seated convictions shaken in the name of advancing knowledge? Leave your frank opinion in the comments on which theory seems more plausible, or propose your own wild ideas. Your input could be the spark that ignites the next scientific revolution.